This is chapter 26, example 1, and what we have here is a circuit that outputs a 4-bit binary count, or 0. So if the button's pressed, it outputs the count. If a button is not pressed, it outputs 0. Binary up counter that always counts up, whether the button is pressed or not, which means when the button's not pressed and it's outputting 0, the counter in the background is still counting. So this circuit, first starting this circuit, is top level black box diagram with a 4-bit output, which we'll call the count. It has a button input, and we know this is synchronous. We'll put a clock in that too. The second step in the circuit is to take inventory of the modules we'll need to do this circuit. And so the idea here is what we see is it needs a counter, so we'll draw a 4-bit counter. The output of that counter is going to be our count. Counters are synchronous, we'll put a clock in there. It's listed as an up counter that's always counting up, so we can tie that up signal to positive logic. It looks good in that sense. And I've already made a mistake. So the second part of this problem is it needs to choose between outputting the count and 0. And so the issue on this one is this isn't the count output. It needs to make a decision. The decision calls out for mux, and so this is going to be the circuit. Now this is outputting the count or 0, so we can ground this. This is still 4-bit. The thing that's controlling the mux is the button. Clock comes from the outside, and so we're almost done with this circuit. We need to declare numbers on this mux. This is 2-to-1 mux. Essentially the button's pressed, it outputs the count, so this is going to be a 1 and a 0. Notice that we can very easily do the circuit without a state machine, like without an official FSM, although you can argue the counter is a state machine of some sorts. We don't need any controlling circuit on this. So what controls this circuit is this thing right here. This mux has a control input, which is the select input right there. It's controlled by a button, external. And you can argue that this is a control input to the mux, and it's covered by an internal signal, and so you can argue that this also has internal control. One final check through on the circuit. Everything's good, everything matches, everything's labeled. Call it done.